Section 3.2, Negative Exponents. Up to this point, we have talked about exponents, but only positive exponents. In this section, we will start a discussion about the meaning of negative exponents and what the rules of negative exponents are. Let's say that you have a number with a positive exponent. For instance, if you have 5 to the third power. 5 to the third power means 5 times 5 times 5, which is equal to 125. So I'm going to set up a little pattern here. We know that 5 squared is equal to 25. We know that 5 to the first is just equal to 5. Take a look at the pattern that I have. For each one of these, I am decreasing the exponent by 1, from 3 to 2 to 1. What happens to the answer when I do that? Well, you can see that what I'm doing is I am dividing by 5, whatever the base is, to get to the next answer. So 125 divided by 5 gives me 25. 25 divided by 5 gives me 5. Well, the rules have to be the same as I continue the pattern. So if I say, well, 5 to the 0 power, what's 5 to the 0 power? 5 to the 0 power would have to be 5 divided by 5, and 5 divided by 5 is equal to 1. So 5 to the 0 power is equal to 1. As a matter of fact, because of this pattern, it doesn't matter, anything to the 0 power is equal to 1. I have 5 to the 0 power is equal to 1, but 6 to the 0 power is equal to 1, 3 to the 0 power is equal to 1. Anything to the 0 power is equal to 1. But let's continue this pattern just a little bit more. If I would now say, well, how about 5 to the negative 1? Well, 5 to the negative 1, in order to get that answer, I would have to divide once again by 5. 1 divided by 5 is equal to 1/5. So 5 to the negative 1 is equal to 1/5. If I go and continue with this pattern, 5 to the negative 2, I would have to divide 1/5 by 5. If I divide this by 5, I'm going to do the work over here. 1/5 divided by 5, it actually means 1/5 times. I'm going to flip this. Instead of 5 over 1, it would be 1 over 5. I would get 1/25. So 5 to the negative power is equal to 1/25. And let's analyze that for a little bit. I'm going to rewrite what I just circled over here. 5 to the negative 2 is really equal to 1/25. It's equal to a positive 1/25. Many people think, boy, this is a negative 2, it must be a negative number. It is not. And the reason it isn't is because of the pattern that I just showed over here. But when I have 5 to the negative 2 and I know it's equal to 1/25, there's an easy way of figuring out the answer. What I'm going to do with 5 to the negative 2, if I want to figure out what that is, what I can do is I can bring that 5 to the negative 2 down to the bottom and make that a positive 2. So if I did that, I would have 5 squared down at the bottom. I would still be left with a 1 here because I could have had a 1 times 5. And 5 squared, once again, is 25. So I actually get 1/25 as I go through and do that. Before we start talking about negative exponents and variables, let's just review a little bit once again just with negative exponents and what to do if you have a negative exponent. Let's say that I had 6 to the negative third power. One of the rules of math states that you can never have a negative exponent. You always have to change it to a positive exponent. Now, I have 6 to the negative third power. I'm going to write that as a fraction. 6 to the negative third power over 1. Whenever I try to get rid of a negative exponent, I always think about driving on a highway that has orange barrels. You see those orange barrels and it tells you to go to the other side. I think about that whenever I have to deal with a negative exponent. Since this is a negative exponent, the way to get rid of the negative exponent is to move the base and the exponent to the other side of the fraction. So instead of that 6 to the negative third being at the top, I'm going to have 6 to the positive third. I'm going to change it to a positive. I'm going to put it in the other side of the fraction. Now once again, there's an understood 1 out here, so I would have 1 over 6 to the third. And if I figured out 6 to the third means 6 times 6 times 6, so that answer is 1 over 216. The same thing works if I have something that's already in the bottom. Let's say that I had 1 over 5 to the negative second power. I can't have a negative exponent. So what I'm going to do is I'm going to move the base and the exponent, both of them, up to the top. Think about those orange barrels. I'm going to move to the other side, and I'm going to make it a positive. So what I have is I have a 5 over 2. I'm sorry, not 5 over 2, 5 to the second power over 1. So I get a final answer of 25. So 1 over 5 to the negative 2 is really equal to 25. So let's simplify this one, and this is one that does have a variable with it. And that variable x has a negative 3, a power of negative 3 attached to it. You need to rewrite this so it does not have a negative exponent. So what I am going to do is I'm going to take the base and the exponent and I'm going to move it to the other side of the fraction, and I'm going to make it a positive exponent. The 4 would stay at the top. The 5 is going to stay at the bottom because I'm not doing anything with that, but I would have 4 over 5x to the third if I wanted to go through and change that so it does not have a negative exponent. These are equal to each other, but mathematically I cannot have a negative exponent, so I would need to write it like that. Here's another example. If I had something like 6 over 3x to the negative 7, and now the negative 7 is on the bottom, I have to get rid of the negative 7. I'm going to move that along with its base to the top. I'm going to keep everything else where it is. So the 6 stays up at the top. It becomes x to the positive 7, and it's still over 3. If I wanted to reduce this even more, the 6 divided by 3 cancels out. I get 2, so my final answer to this is 2x to the 7th power. The same laws that we talked about with positive exponents in the last section also work with this section. If I have x to the negative 2 multiplied by x to the third power, I can go through and just add these exponents that I have because I have exactly the same base. So negative 2 plus 3 is equal to 1, so I get x to the first, which I could also just write as x. Now, there is another way that I could also go through and do this. I'm going to rewrite the problem the way I had it, x to the negative 2 times x to the third power, and I see that I have a negative 2. Remember, anytime that you have a negative power, you could always move it down to the bottom. So the other thing that I could do is I could create a fraction, and I would move this down to the bottom and make it x to the positive 2. So now what I have is I have x to the third over x squared, and now I could once again use another one of the rules that we talked about in the last section. Since I am dividing and I have the same base x, I can subtract my exponents. 3 minus 2 is equal to 1, so I get x to the first power, or x, which is the same thing. Let's take a look at another one. If I have x to the negative fifth power times x to the negative fourth power. Once again, there's two different ways you can do it, but one of the ways you could do it is I could use the law of exponent, where I'm just going to go through and I'm going to add these exponents. Negative 5 plus negative 4 gives me a negative 9. So I have x to the negative ninth power. But remember, according to the rules of math, you cannot leave a negative exponent. So I would need to go through and I would need to get rid of that negative exponent. I'm going to think about this as x to the 9 over 1. And then what I'm going to do is I'm going to move all of this down to the other side of the fraction and make it a positive. Just remember doing that, there was an understood 1 in front of that x, which is going to stay on the top. So my final answer to that is 1 over x to the 9th power. I had mentioned to you that there were a couple of ways you could do it. Here was that original problem again, x to the negative 5th times x to the negative 4th. The other thing that I could have done is right away I could have changed both of those, and I could have put both of those back down to the bottom. So I could have, if I had wanted to, moved x to the negative 5th down to the bottom and make it x to the positive 5th, move my x to the negative 4th down to the bottom, make it a positive 4. Remembering that there's a 1 on the top then, I would have x to the 5th times x to the 4th on the bottom, and then I would use my rules that we talked about in the last section, add together the 5 plus the 4, I still get 1 over x to the 9th. It doesn't matter as you go through and do this which way you do it, you just have to make sure that your final answer, you do not have any negative exponents. Take a look at the two different problems I have on this slide and notice that they are very similar, but they give very different answers. Let's take a look at the one on the left. The one on the left says 5 times x to the negative 2. And the only thing that I have to the negative 2 power is the x. So because of that, the only thing that's going to be moving to the other side of the fraction is that x, and I'm going to change that to a positive 2. The 5 would still stay on the top. The x to the negative 2 would move to the bottom. I would have a final answer here of 5 over x squared. On the other one, notice that both the 5 and the x, because they're in parentheses, are to the negative 2 power. So for that one, I'm going to think about this as something over 1 creating a fraction, but then this entire part is going to be moving down. Now once again, remember there's an understood 1 here, so I'm going to have a 1 on top, and I'm going to have a 5x. Once again, I'm going to put that inside the set parentheses, and it's to the 2nd power. Now I have to go through, I have a power, I have to take both of these factors to the 2nd power. 5 squared is 25. I have x squared, so I have 25x squared, and the final answer to this one is 1 over 25x squared. This is the area right here, the one over to the left, that a lot of people tend to struggle with. Just remember the way it's written, I cannot take this 5 down because it's not 5. The 5 is not to the negative 2. The only factor in there that's to the negative 2 is the x, which gives me that answer of 5 over x squared. Here I have two problems dealing with the last rule that we talked about in section 3.1 when you are taking a power to a power. And once again, the rules work exactly the same way. The one to the left, I have b to the negative 4th and that to the negative 2 power. There's all sorts of different ways of doing this, but when I do this, I can multiply negative 4 times negative 2. Negative 4 times negative 2 gives me 8. So the answer to this, the final answer, is simply just b to the 8th power. When I take a look at the one on the right, remember, anything to the 0 power is equal to 1. So I can really get rid of this right away and just say, well, that's equal to 1. Now I have b to the negative 4th to the 3rd, and I'm going to multiply negative 4 times 3. So I get b to the negative 12. I can't leave it as b to the negative 12 because I can't leave a negative exponent. So I am going to bring that down to the bottom. Remember, there's that understood 1 in front of that b. And I am going to make this b to the negative 12 a b to the positive 12. So my final answer to this is 1 over b to the 12th power. There's one more idea found in this section called scientific notation. However, this video is already long enough, so to see the information on that, please see the Section 3.2 Part 2 video. Thank you.